Hi everyone, so this is the unit review for Unit 10b, our rational expressions. And the key, I already did the key, so I'm just going to talk to you about the questions and give you some tips and pointers here. So for number 10, the rational expression can be simplified to which of the following? We're just going to want to factor the top and factor the bottom, using QT on the top, dots on the bottom, and then those parentheses will cancel. So our answer is 4. Number 11, when the square of a number is decreased by 9, then divided by 6 less than twice the number, what is the result? So you're going to want to factor that top and bottom, cancel. The result is going to be 1/2 of 3 more than the number. So technically you can rewrite this, pull the 1 and 1/2 out, and that's what it would match up there with number 3, or for number 3. Number 12, we're going to want to keep, change, flip, and in the process of doing that, I'm going to simplify this parenthesis here. So if we remember exponent to an exponent, we are going to multiply those together. So that's how I got that there. Then I did a little bit of canceling, but as I mentioned before, sometimes it gets really difficult canceling a whole bunch of things out and seeing what's actually left. So I would recommend doing top times top, bottom times bottom, and then from that single fraction, reducing down. Now notice they also have a negative. I would normally not want that, but that's going to be what our answer is for this particular question. Number 13, which of the following represents the sum? So we're going to want to get common denominators and then just add the tops together to get our answer. And for 14, it's a subtraction of 2 fractions. So again, common denominators, we already have that, but we want to be careful to distribute this negative sign to both of the parts in the numerator so that we don't incorrectly combine like terms. And basically the whole entire numerator gets on the top and the common denominators on the bottom, and then we can factor from there and reduce to cancel. Now remember that when you cancel exact opposites, it reduces to -1, not just a +1. So in order does matter obviously here. So make sure you do that factoring correctly, and then canceling out to be -1 leads us to our choice here of 1. All right, the next page, number 15, we have a complex fraction, so we're trying to cancel all the denominators. Our least common denominator is going to be x, so everybody gets multiplied by x. We cross them off here, and we see the result is choice 3. Number 16 is also another complex fraction, but we see we have a lot of different parts to this. Notice this denominator is 1, so technically I'm just looking at these two denominators, so I have to multiply by an x and an x plus y. Make sure you remember you can't just multiply by an x plus y because you can't cancel parts of your binomial. So like you couldn't cancel that x with that part of the binomial. So we definitely have to have the monomial x and then the binomial x plus y. So then that will cancel. We'll get a lot left over in our denominator. But as we see, we're going to take this -1, and that's going to be distributed to the leftover piece that we put there, causing those x's to cancel. And then I didn't distribute because, again, you want to make sure that you've canceled all the way before any distribution happens if you want to do that, to cancel those out. So those are monomials. They can cancel out together. And then, like I said, notice my answer here, they just went ahead and distributed through. So this would be fine to be left as is, or you could write it like this. Number 17, we are... this one is a little bit of a tricky question. So we want to understand that it says the quotient can be written as. Now we can't cancel this, so they're kind of seeing, are you tempted to cancel the x's and maybe choose -5? We definitely can't do that. So they want to know what else could this be represented as. So I went ahead and tried number 2 to get common denominator. So I took that 1 and I just made it an x plus 2 over x plus 2 because that still equals 1, but that made it common with that. And then as I added the tops together, I do end up getting a 2 minus 12, which gives me my negative 10. So right away with that question, I saw that that quotient is exactly the same as 1 minus 12 over x plus 2. Number 18 is a question from the previous unit. So technically that is not going to be on our test, but basically it was just a long division remainder question, definitely something that you should still know how to do. And same thing with number 19. That was a remainder theorem question. So which of the following factor is a factor? If we go ahead and put negative 10, positive 2, positive 7, negative 5 in for x, we see which one results in a 0, which would mean it is a factor. So feel free to review those questions, but those are not something that you have to study for the test. And number 20 also. So number 20, what's the remainder? I chose to do the synthetic division for that case, but again, not on test 10b. 21 will be something on test 10b, where you have to realize that an equal sign between two fractions is called a proportion, and we solve proportions by cross multiplication. So you want to go ahead and cross and multiply, do your distributions, get all the x's, everybody on the same side, and then start to factor. You had to GCF out that 2, and then factor that trinomial. You got 5 and 6. They said, what's the smallest solution? So 5 is the smallest out of those two choices there. Number 22, which of the following represents the solution set? So here's a fractional equation. I like to, again, cancel the denominator, so I multiply by the least common, and that's going to be x squared. So multiplying everybody by x squared cancels all the denominators and results in this. And then we go ahead and move everything over, equal to 0, to factor, to solve, to identify the answers. Number 23. This question we have our inequality. So I could have solved this, by finding the zeros, finding the undefined, graphing the number line, looking at the calculator, seeing, where it's less than 0, and then graphing it to see which one was in that solution set. But because this is a multiple choice question, I just went ahead and substituted the values in to see if it was true or false. So 2 was the only one that ended up being a true statement and in the solution set. Number 24, I decided to do the whole problem out. So again, temporarily changing this inequality symbol to an equal sign, creating a fraction on the other side causes cross multiplication, and then solving for x. So 9 over 2, or 4.5, is our first critical value. That's our 0. And because it does not have a line underneath it, I have an open circle right here. And then x cannot be equal to 1. So again, that's another critical value, definitely open circle there. I go ahead and I put this whole left side in my graphing calculator, and I look and I picked 0, 2, and 5. So again, you're picking one in each interval, a number in each interval to test. And so I test it, and then I have, 9 is bigger than 0. Negative 5 is not, and a 4th is. So I have my completed graph, and I match it to the set builder inequality notation that we have here is choice 3. All right. Number 28. Determine any values of x that do not lie in the domain. So this is basically what values are undefined. We focus in only on the denominator because the denominator cannot be 0. So we're figuring out when will the denominator be 0, and those are the values that do not lie in the domain. Again, we had to factor using guess and check, and then get and solve for x. Number 29, we are for this function, determine the value of the inverse. So now this particular question doesn't actually ask us for the equation of the inverse. It's asking us to determine the value of the inverse when x is negative 1. So a couple different things we can do. We could definitely we definitely have to switch the x's and the y's for the inverse, but we don't have to solve for y to create the inverse equation. What we could do is still flip the x and the y, but then just immediately put the -1 in for the x. So that is just a time-saving strategy for you. You can certainly do it the other way. It would absolutely work. But then, because you don't have an x, you don't have to factor out the y, you don't have to go through all those motions that we practiced when you do have to write the equation of the inverse in y equals form. So then you just go ahead and cross multiply, do your distributions, and solve for y to get that answer there. Number 30. Just be careful with this particular question. You know, sometimes we try to factor this bottom and try to cancel. We can't do that. This is, you know, two different parts on top. So we definitely, it's not like it's 4 factors. It's separated by a minus sign. So we can't just go ahead and cancel. So the first thing we want to do is, I recognize that there is a common parenthesis x plus 5. So I thought it was easier to GCF that out. And then writing what's left over. Again, being careful of that negative sign in front of that parenthesis. So that has to distribute in making those guys negative. So that particular question there, that's a little bit tricky, that first step. But once that first step happens, you clean up this parenthesis, and that's what you get. And then notice when you clean it up, you have another GCF of a 2. So I GCF that 2 out. I wrote what was left. That one I just moved to the end. And then I factored the denominator, see if something could cancel. It can, so I do it. And then I get my final answer right here. Number 31, we want to go ahead and do our keep, change, flip because it's a division. So we're going to factor GCF. That's a monomial. We're going to flip, so the bottom is coming to the top. That's a QT. And then this is a dots. Again, remember order matters here. So since the 36 is first, the 6 and the 6 must be first. And then we want to go ahead and cancel those. Those are complete and exact opposites, so they reduce and cancel to be a -1. Also, these right here, x plus 6 and 6 plus x, those are exact equals, so you want to make sure to cancel those out, and those are positive ones. Then, instead of doing some more canceling, I decided to see what was left on top, write it, see what was left on the bottom, and write that, and then cancel some more out, just so there wouldn't be so many crossing off over there. So that's going to reduce to a -1/2, -1/2. That one monomial x will cancel with one of those, leaving one in the bottom, and then there's the parenthesis for the final answer. Number 32, we have an addition of fractions. So we want to remember when we're trying to add fractions, add or subtract, we need common denominators. So definitely factor those denominators first to see something, to see if one of the factors is already in common, and it is, that x plus 4 is already in common. And then we look at what we need on each side. This one had a single x, so now we put one there, do to the top. This one had an x minus 1, so we need it over here. We do the bottom, we do to the top. Then, as you recall in class, I really tried to stress that you need to, from these two parentheses, it's very helpful to immediately write it as one fraction. You don't want to get caught up in writing two separate fractions. That just creates you writing that denominator, that common denominator, twice, which is tedious to do, to write that twice and then still have a lot of stuff in the numerator. So if you always remember that once you have those common denominators, which you should be doing in your first step, you immediately write it once in the next step, and then every single part across the numerator, you can write all that, write the whole numerator up there. Combining like terms, factoring, and then canceling, writing what's left. Please make sure you're knowing what can and cannot cancel. So this is a binomial, this is a binomial. Since they're not exactly the same, they cannot cancel. This is a monomial. You can't cancel that with part of that binomial there. So that is the final answer that we can go to. No more canceling can be done. Number 33, we have a complex fraction. So fractions over fractions, we want to cancel those mini denominators. Multiply again through to cancel those out by a 5x. Once we do, this is what we're left with. and then we want to factor that. Again, we cannot cancel until we factor. So we factor, we see a common parenthesis, and then we're going to reduce down to x, 10 over x minus 5. Number 34 is a question from Unit 10A. So while it's, again, good to review, it is not something that's going to be asked of you on your 10B test. So you have your long division, and then you have whether it is or is not a factor answers there. So you can certainly get those down, but again, don't put your time into reviewing long division or synthetic division, because that was on test 10A. Same thing for number 35. Number 35 was a 10A question, so we do not need to review that. Number 36, definitely a question within this unit, going to be on your test. So we see we have a fractional equation. We want to cancel the denominators. So factor this bottom, we see we do have matching denominators. Not that we need it for common denominators, but we want to make sure that we multiply through to cancel the denominator with the smallest amount of parts. So we're going to multiply through by an x minus 2 to cancel, and then we write what's left. That parenthesis will cancel, we write what's left, and then that whole thing will cancel, and we write what's left. Then we do our distributions, we combine our like terms, we factor, we solve, and we have to remember to go back up and look that x can't be 0, x can't be 2, so that's an extraneous value. So we're going to just choose -7. That's the only answer here. Number 37, definitely review number 37. There was a multiple choice question similar, but this is definitely something that you're going to need to know for the test. So here we have a simple fraction, an inequality. We're going to go ahead, temporarily change that to an equal sign, create that fraction to cross multiply, and then solve for x. So there's our 1, 0, our root. Because it does have a line underneath it, I do have that closed circle there. Undefined, we look at the denominator. X cannot be -3. So -3 is open circle, because that's where it cannot be equal to. It'll cause that denominator to be 0. And this is what we discussed in class as well, that when we go into our y equals part of our calculator, we really want to always be comparing it to 0. So we're going to subtract that value over to the other side, or if it was negative, we would add it over, just move it over to the other side. Your calculator, put that whole part into your y sub 1, and then look at those values you choose in the intervals around your 0 and your undefined value, your critical values. So I chose -5 right here, I chose 0, and then I chose 10. So comparing it to is it greater than or equal to 0? Definitely true, false, true. So I knew that I would shade over those values, and then I would write it in interval, but make sure you also know how to write it in set builder notation. This is set builder notation. This is interval notation. Make sure you know how to write it in interval notation. Hint, hint. Okay? 38 is another question similar to that. So we have our, it's already equal to 0, or we will temporarily change it to an equal sign, cross multiply,